Hi everyone, this is Ms. Cheryl. I'm going to be going over the 5-1 to 5-3 quiz review worksheet with you in this video. A few things I want to say about this before I get started. There are solutions to this assignment that will be posted on my website. If you've already worked through the problems on your own, go through and check the solutions first. If you get the answer correct and you're feeling good about it, you may not need to watch the video for that problem. You can definitely skip forward, throughout the video to just focus on the questions that you need. So try to make the best use of your time. Now, if you are watching this video and you have not worked through this assignment first on your own, and you're watching the video and you're just going to kind of learn from it and take some notes along the way, know that that's not enough to prepare you for the quiz. If you really want to be prepared for the quiz and that's the approach that you're taking, you're going to need to make an alternate version of the quiz review worksheet for yourself and then actually work through them on your own. So you can find similar problems in your textbook. The textbook is full of them. You can look at previous homework problems that we've assigned or previous problems that we've worked through in class. But just know that the way that you study for math is not by listening and watching somebody else work through problems. The way that you study is that you have to work through them on your own. You do want to make sure that you understand what you're doing, but I can't do the work for you on the quiz, so make sure that I'm not doing the work for you on your review. Okay, so first section, writing expressions in simplest form. It's a little different from the identities that we've been doing because there's not an equal sign. It doesn't tell us what the goal is. This is just kind of warming us up, helping us to practice some of our skills. Oh, and by the way, before I start with this, so you should have out in front of you your formula sheet. You're going to have your formula sheet for the quiz. You're also going to have a filled in unit circle for the quiz. And then I'm also going to give you a 4-function calculator. All it does is just add, subtract, multiply, and divide. So it's really helpful, I think, to know the exact tools that you're going to have with you on the quiz, so you know those are the tools that you can have with you as you're studying and preparing. Okay, so for the first expression, we could rewrite this as sine over 1 times sine over cosine. And just keep this as cosine. We can write it as cosine over 1. So this would be using the strategy of rewriting everything in terms of sine or cosine. That means if it's already a sine or a cosine, just keep it as itself. So the only one that I changed was tan. Now I'm going to multiply these two fractions here. So I have sine squared over cosine. Then I'm going to think about getting a common denominator. So to do that, I'm going to multiply the top and bottom over here by cosine. And that's going to give us sine squared over cosine plus cosine squared over cosine. So we'll go ahead and add across the numerators and keep our denominator the same. And then from our formula sheet, or hopefully from your memory by now, sine squared plus cosine squared is 1. So you can just write it as 1 over cosine squared, 1 over cosine of x. The directions are kind of funny here. It says using only sine or cosine. So you can just leave it like this. Really, it's the same thing as secant. It won't be ambiguous on the test because you won't have, or on the quiz, because you won't have any like this on the quiz where you're just simplifying. The only thing you'll have on the quiz is actually verifying, so you're going to know exactly what your goal is. Okay, for number 2, I'm going to do the same strategy of rewriting everything in terms of sine and cosine. So we've got 1 over cosine times cosine over sine. This one's really nice. They're just being multiplied, so you can cross cancel the cosines and leave it as 1 over sine, which is really the same thing as cosecant. Okay, now we're going to get into actually verifying. So in number 3, I'm going to set the right-hand side for my goal, and the left side is a form of difference of squares. If you think of a to the 4th minus b to the 4th, you can factor that into a squared plus b squared, times a squared minus b squared. If you were to multiply this out with FOIL, you're going to see that it's the same thing as this. So it's kind of like the difference of squares, think about x squared minus 25. X plus 5, x minus 5. But we're doing it with a and b, it's to the 4th, so we're going to keep our squares on the inside. So we'll go ahead and factor this into secant squared plus tan squared times secant squared minus tan squared. Okay, from our formula sheet, I'm just going to make a note here off to the bottom. On the formula sheet, 1 plus tan squared is secant squared. So if we subtract tan squared from both sides, we get that secant squared minus tan squared is 1. Secant squared minus tan squared is 1. So that's 1. 1 times anything is itself. And that's our goal, secant squared plus tan squared. Okay, for the next one, I think I'm going to try having the right side be the goal again. I'm going to rewrite the left side in terms of sines and cosines. So tan squared is the same as sine squared over cosine squared. Secant is the same as 1 over cosine. Then I'm just going to divide the fractions. So I'm going to keep the first fraction the same, and I'm going to multiply by the reciprocal of the second fraction. And that's going to allow me to cancel a cosine. Remember, there are many correct ways to verify. You might have taken a different approach on this one and still have a completely correct proof. Okay, so I've got sine squared over cosine. Now's a good time to look at my goal. I've got a subtraction sign in the goal, and so I'm going to think about trying to make a replacement that's going to introduce a subtraction sign into the problem. So I'm going to replace sine squared with 1 minus cosine squared. Then I'm going to use a strategy that you can do anytime you're adding or subtracting in your numerator. You can actually split your fraction apart, keeping your denominator the same. So I'm going to write that as 1 over cosine minus cosine squared over cosine. And if you think about our goal that we're working toward, the 1 over cosine is the secant part of our goal. Cosine squared over cosine, we could cancel a cosine, so then we're just left with cosine, and that's our goal. Secant minus cosine. Okay, next identity here in number 5, let's set the right side to be our goal. Let's rewrite these two fractions to get a common denominator. So the way we'll do that is we'll just multiply our denominators together. So you're going to think about multiplying a cosine in front of the original denominator. If you multiply a cosine down here, you also have to multiply a cosine on the numerator. And remember, this entire thing right here, that's a fancy form of 1. If you multiply by cosine over cosine, it's the same thing as multiplying by 1. Okay, let me recopy the second fraction. And kind of similar idea, but to get the denominators the same, this time we'll have to multiply the top and bottom by 1 minus sine. So notice how now our denominators are the same, but we have some simplifying that we can do over here on our numerators. So I like to simplify my numerators first before adding or subtracting. So that's the first fraction. To simplify this one, we're going to have to do FOIL. 1 times 1 is 1. The outside is negative sign. The inside is also negative sign. So I'm actually going to write that as negative 2 sine. Minus sign is negative 2 sine. And then negative sign times negative sign is positive sine squared. Okay, now I'm going to add across the numerators and keep the denominator the same. Okay, now on the numerator, something that's sticking out to me is that cosine squared plus sine squared is 1. And we already have a 1 there, so that's going to turn into 2. Okay, the next thing that sticks out to me on the numerator is that there's a common factor of 2 in both of the terms. And so I'm going to factor out the 2, leaving me with 1 minus sine. We'll recopy our denominator. All right, now we can do some canceling. So from the numerator and denominator, we could cancel the common factor of 1 minus sine. We're left with 2 over cosine, which is the same as 2 times 1 over cosine, which is equal to secant, and that was our goal. Okay, for number 6, I'm going to set the right-hand side as my goal. I'm going to think about the strategy of rewriting this in terms of sine and cosine. And then I'm going to get a common denominator. So am I going to do that? Yeah, let's do a common denominator. So let's multiply this first fraction by sine squared over sine squared. Let's multiply the second fraction by cosine squared over cosine squared. Okay, so now I'm just going to add across the numerators. It's really just going to be sine squared plus cosine squared. Keep our denominator the same. Sine squared plus cosine squared is 1. And then what we can actually do with this is you can think about this as being 1 over sine squared times 1 over cosine squared, because if you multiply across the top and multiply across the bottom, you end up with this. 1 over sine squared is cosecant squared. 1 over cosine squared is secant squared, and that's our goal. Okay, for the sum and difference formulas, these are going to be from our formula sheet. So the idea here is that you want to find two angles that add or subtract to 105 degrees. So I'm going to choose, and we want to choose angles from the unit circle. So this is why you're going to have a filled out unit circle given to you as one of your resources. So I'm going to choose 60 and 45. Now we're going to rewrite this using our formula sheet. Cosine u plus v is the same as cosine u cosine v. In this case, u is 60, v is 45, minus sine u sine v. Whatever you do, do not do the cosine of 60 plus the cosine of 45. It does not distribute. Okay, from our unit circle, cosine 60 is a half. Cosine 45 is root 2 over 2. Sine 60 is root 3 over 2. Sine 45 is root 2 over 2. So we're going to multiply with fractions, multiply across the top, multiply across the bottom. So we get root 2 over 4 minus root 6 over 4. All together we have root 2 minus root 6 over 4. We cannot simplify any further. Okay, for the next one, so to think about the pi over 12th situation, I'm going to open up a new page here just to give you guys some things to think about. So we're wanting to think about our unit circle angles, rewriting them as 12ths. So pi over 6 is the same as 2 pi over 12. Pi over 4 is 3 pi over 12. Pi over 3 is 4 pi over 12. We could even do pi over 2 is 6 pi over 12. So I'm going to think about those. I'm going to think about two of them that would subtract to equal negative pi over 12 or negative 1 pi over 12. So there's a couple ways you can do it. You could do 2 pi over 12 minus 3 pi over 12, or you could do 3 pi over 12 minus 4 pi over 12. That's the one that I'm going to do. I'm going to do 3 pi over 12 minus 4 pi over 12 because that's equal to 1 pi over 12. And what I'm really doing is it's really pi over 4 minus pi over 3. Okay, so from my formula sheet, I'm just going to rewrite that so I remember. Pi over 4 and pi over 3. So from the formula sheet, cosine of u minus v is cosine u cosine v plus sine u sine v. Okay, now we're going to go to the unit circle. So cosine pi over 4 is root 2 over 2. Cosine pi over 3 is a half. Sine pi over 4 is root 2 over 2. Sine pi over 3 is root 3 over 2. All right, whoops. Multiply. Multiply across the top and multiply across the bottom. So you get root 2 over 4 plus root 6 over 4. And just add the numerator. keep the denominator the same, cannot simplify any further. Okay, for the next one, sine of negative 195, we're going to think about two unit circle angles that would subtract to equal negative 195. So I'm going to do 30 minus 225 because that equals negative 195. Now I'm going to go to the formula sheet. On the formula sheet, it says that sine of u minus v is sine u cosine v minus cosine u sine v. U is 30, v is 225. Okay, so sine 30 is a half. Cosine 225 is negative root 2 over 2. Cosine 30 is root 3 over 2. Sine 225 is negative root 2 over 2. Okay, so we're going to multiply across the top, multiply across the bottom. You get negative root 2 over 4. This is minus what's going to be negative, so it's just going to be plus, and then multiply across the top, multiply across the bottom, add across the top, keep the denominator the same. Do not simplify your answer any further. Okay, for the next one, this is 12ths, so I'm going to think about what I did over here with 12ths. I want to make 5 pi over 12, so I'm going to do 2 pi over 12 plus 3 pi over 12. Okay, and so that's really pi over 6 and pi over 4. Using my formula sheet for sine u plus v, we're going to do sine u cosine v plus cosine u sine v. So u is pi over 6, v is pi over 4. All right, so the sine of pi over 6 is a half. Cosine pi over 4 is root 2 over 2. Cosine pi over 6 is root 3 over 2. Sine pi over 4 is root 2 over 2. Okay. Multiply across the top, multiply across the bottom to multiply each pair of fractions. Add across the top, keep the denominator the same. Do not simplify your answer any further. We can't. Okay, the last one, 13 pi over 12. Okay, let's think about what we did with the pi over 12. What we have here is, if we try to put these combinations together, it's not enough to give us 13. So let's think about, this is just in the first quadrant. Let's think about moving into some of our other quadrants. Okay, so I just wanted to bring up the top half of our circle so that we can think about our angles and radians in terms of 12ths. So pi over 6 is 2 pi over 12. This is going to be 3 pi over 12, 4 pi over 12. Pi over 2 is the same as 6 pi over 12. Let's go into the second quadrant. So 2 pi over 3, I'm going to multiply the top and bottom by 4, so I get 8 pi over 12. 3 pi over 4, I'm going to multiply the top and bottom by 3, so we get 9 pi over 12. 5 pi over 6, let's multiply the top and bottom by 2, so you get 10 pi over 12. So this is going to give us some more tools to work with. So if we want to make 13 pi over 12, there's a few different ways we can do it. So you could do 10 pi over 12 plus 3 pi over 12. You could do 9 pi over 12 plus 4 pi over 12. So either one of those combinations, and then we're actually using unit circle angles. So let me go back here. So for mine, I think I'm going to actually split this into, I'm going to do 9 pi over 12 plus 4 pi over 12, which is really 3 pi over 4 plus pi over 3. Okay, so now I'm going to use the formula for tan of u plus v. So from the formula sheet, it's tan u plus tan v over 1 minus tan u times tan v. Okay, and then I'm going to start to fill these in. So the tan of 3 pi over 4 is negative 1. The tan of pi over 3 is root 3. All right, we'll simplify a little bit on our denominator. That's going to be 1 plus root 3. Okay, so for the purpose of the quiz and the test, you may have to check with Ms. Paloma to see if she's okay with this, but I'm okay if you just leave your answer in this format. I do, however, want you to know that there is a way to rationalize the denominator in a situation like this. So the way that we rationalize this denominator is we're going to multiply by what's called the conjugate of our denominator. So the conjugate, it's like the same thing, but one's plus and one's minus. So we're actually going to think about foiling when we multiply. So let's look at the denominator part first. So you're going to do 1 times 1, which is 1. The outside is negative root 3. The inside is positive root 3. So those cancel. And then root 3 times root 3 is 3. So that's how your denominator gets rationalized. It's going to turn into negative 2. Let's go ahead and FOIL on the top. So when we FOIL on the top, we get negative 1 plus root 3 plus root 3 minus 3. So we're going to do negative 1 minus 3 is negative 4. Root 3 plus root 3 is actually 2 root 3. And then what we can do here is actually divide out a common factor of 2 from everything. So it's going to be negative 2 plus root 3 over negative 1. What we could then think about is do negative 2 divided by negative 1, which is 2. And then root 3 divided by negative 1 is negative root 3. Okay, so let's turn over to the back side. So we're going to continue to think about using our formula sheet. For number 12 and 13, we're going to find the value of cosine x minus y. And so we want to think about cosine u minus v. We're just doing x and y instead. So from your formula sheet, it's cosine x times cosine y plus sine x sine y. So you're going to need to write this out on your paper first. We're going to use the information they've given us to draw and label some triangles to help us give us all the information that we need. So they've given us cosine x and cosine y, so that's good, but we have to draw and label the triangle in order to figure out sine x and sine y. So it's telling us the quadrant that it's in, so it's telling us that angle x is in the third quadrant, so I'm going to start by drawing and labeling that one. And make sure you write an X in the corner there so you know which one it is. Cosine is adjacent over hypotenuse. I already know, because it's a 3, 4, 5, I already know that this is going to be 4, but make sure that you make it negative. All right, the second angle, angle Y, is in the fourth quadrant, so let's just do it on the same picture. Label it Y. Cosine is adjacent over hypotenuse, another 3, 4, 5, so this is going to be 3, but make sure you make that negative. Okay, so if we think about, I'm actually just going to, I know I wrote it up there, but I got to rewrite it so you guys know exactly where all these pieces are coming from. So cosine x, you can look at your picture or you can just look up here, it's negative 3/5. Cosine y is 4/5. Okay, now let's look at our picture to find sine x. It's opposite over hypotenuse, so it's going to be negative 4/5. Sine y is negative 3/5. Okay, now you're going to follow order of operations to multiply. Oh, and this one's weird. I remember this one. Yeah, it just ends up being 0. Okay, let's do this for the next one. So our first angle is in the first quadrant. So always start with a picture. Oh, and there's a typo. It's missing an x. Write an x in there. Okay, so that's our first angle. Cosine is adjacent over, ooh, this one's also weird, adjacent over hypotenuse. Oh my gosh, be careful with the numbers because it looks like it's going to be a 5, 12, 13, and it's not. Because the 13 is not on the hypotenuse. Now this is going to be a little bit oh shoot, I wish I would have made this change before I made the copies, because on the solutions that I'm looking at, I actually changed that to a 13. So if you look at the solutions, it's going to end up being different. Let's just keep going with it as if it's a 12. We can have flexibility with the numbers, right? So a squared plus b squared is c squared. Let's just see what this turns out. It's supposed to be 25. Okay, 144 minus 25. So 144 minus 5 is 139. 139 minus 20 is 119. So let's write that as square root of 119. Okay, for y, cosine y, this is in the fourth quadrant. I'm going to actually change colors here so that it stands out. So that's y. I think what I actually might do, I'm going to erase that black 5 and put it up here so it's like inside of that. Okay, so cosine is adjacent, so square root 3 over hypotenuse. And let me just open up some space here. We're going to do Pythagorean theorem to find the length of the third side. So I'm going to do a squared plus b squared equals c squared. So we end up getting that b squared is 1, and the square root of 1 is 1, so let's label this as 1, but make sure that we make it negative because it's in the fourth quadrant. Okay, so let's write this out. So cosine x minus y is cosine x cosine y plus sine x sine y. All right, cosine x was given to us, it's 5/12. Cosine y was given to us, it's root 3 over 2. All right, sine x is root 119 over 12. Sine y is negative 1 over 2. All right, multiply across the top, multiply across the bottom, and then subtract across the top, keep our denominator the same. Okay, so that one wasn't too bad, not a big deal. I think what I'm going to do, I'm just going to go back, I'm going to fix it on the solutions, so the actual solutions matches that. Okay, in the next set of problems, we're going to be finding the sine of x plus y, which again, that's one that's going to be on our formula sheet. Let's maybe draw our picture first. Hang on a second. Okay, I am back. So, all right, so the sine of x plus y. So on the formula sheet, it's sine x cosine y plus cosine x sine y. Whatever you do, do not write it as sine x plus sine y. It doesn't distribute. So remember, we talked about that a lot in class. Okay, so we're going to want to draw a picture. All right, so our first angle x, if it's between 0 and pi over 2, that's another way of saying that it's in the first quadrant. Cosine is adjacent over hypotenuse. If we do Pythagorean theorem, I'm going to write it out here, but we're actually going to get that our missing side is 1. This is almost the same calculation we had on the last problem, if you were doing that one with us. Okay, so b is 1. All right, and then let's draw our triangle for y. So if y is between 3 pi over 2 and 2 pi, that's another way of saying that it's in quadrant 4. I'm going to change colors again so that it sticks out. Dang it, I had the same problem the last time. Let's go ahead and just write the square root 3. This little bar is so annoying. It keeps jumping over there. Okay, angle x, and then this is angle y. Okay, cosine is, again, is adjacent over hypotenuse. Let's do Pythagorean theorem to see what we get. So you're going to do a squared plus b squared is c squared. This one actually looks like it's going to work out nice. 9 minus 5 is 4. Great, and the square root of 4 is 2. And then make sure that we make it a negative 2 because it's in the fourth quadrant. All right, so now we have the information that we need to do all of this. So sine x, I'm going to look at the picture. Sine is opposite over hypotenuse, so it's 1/2. Cosine y, you can look at the picture or just look at what they've given you. All right, cosine x, they also gave us that one, √3/2. And then sine y, we need to look at the picture, so it's going to be -2/3. Okay, sorry, I'm going to switch back to black. All right, multiply across the top, multiply across the bottom. Positive times a negative is a negative. What we're going to do on this one is just write it as 2√3. And then we'll combine these by subtracting across the top. Keep the denominator the same. There's absolutely no simplifying that we can do, so leave our whole answer like that. Okay, next set 15 and 16, we're practicing our double angle formulas. This is on our formula sheet. So question 15, we're going to find sine of 2x. One thing we know about this from our formula sheet is that it's equal to 2 sine x cosine x. Okay, first quadrant, so let's go ahead and draw our picture. And sine is opposite over hypotenuse. Yay, this is a nice one. It's a 3, 4, 5, so that's 4. Okay, so let's go ahead and do our calculations. So 2, keep the 2 in front. You can even write it as 2/1. Sine is opposite over hypotenuse, so it's 3/5. Cosine is adjacent over hypotenuse, so that's 4/5. Multiply all across the top, multiply across the bottom, and we get 24/25. Okay, the next problem is in the third quadrant, and question 16, we're going to be finding cosine 2x. So in the third quadrant, that's going to be over here, and cosine is adjacent over hypotenuse. Let's do Pythagorean theorem, so it's going to be a squared plus b squared is c squared. Okay, that one worked out nice. It's 3. It's negative because it's in the third quadrant. All right. Remember the double angle formula for cosine? Remember how there's 3 options? Well, when you're doing these, you can do any of the 3 because they're all equivalent. It doesn't matter which one you pick. I'm just going to do the first one from our formula sheet. For cosine 2x, it's cosine squared minus sine squared. So cosine was -√7/4. I'm going to square that. Sine from our picture is opposite over hypotenuse, so it's going to be -3/4 squared. A negative number squared is going to be positive. You square the numerator, square the denominator. So you get 7/16 minus 9/16. 7 minus 9 is -2, and -2/16 is going to be -1/8. Okay, now we're proving some more identities using the sum and difference and the double angle formulas. Very exciting. Okay, the right-hand side, let's set that for our goal. All right, on the left side, we have cosine 2x showing up in both places. Remember, we have 3 options for how to replace cosine 2x. So you can write it as cosine squared minus sine squared, 1 minus 2 sine squared, or 2 cosine squared minus 1. Okay, so here's what I'm going to think about. So tan squared, I know that that's sine squared over cosine squared. There's no addition or subtraction in the goal. It's just like one thing over another. So I'm going to think about making replacements so that I am getting rid of the addition and the subtraction signs. So what I'm going to do for the first one, the cosine 2x right here, so that's a positive 1 in front, and then it's subtracting. I'm going to choose this one because this has a positive 1 in it so that when it gets subtracted, the 1 minus 1 will cancel out, and it's going to make it so there's no longer subtraction in the numerator. Whenever you make a replacement after a subtraction sign, you have to make sure that you put it in parentheses. Okay, so that's going to be the new numerator. I'm going to think about something similar for the denominator. So for this replacement, this is a positive 1 right there. Hang on just a second. Okay, sorry, I'm back. I just have had a few students stop by and have to ask me some questions. So, okay, so to think about the denominator here. So I have a 1, but then it's adding. So I'm going to choose this option because this is the only one. So it has a negative 1. When that gets combined with that positive 1, those are going to cancel and go away. So I'm going to rewrite the denominator as 1 plus 2 cosine squared minus 1. And if you're making a substitution and if it's after an addition sign, you actually don't need parentheses. You only have to have them after a minus sign because you just got to make sure that you distribute the minus sign. Okay, so let's go ahead and rewrite what we have here. So the 1 minus 1 plus 2 sine squared. So the 1 minus 1 is going to cancel. We're left with 2 sine squared. Over here for the denominator, the 1's cancel, leaving us with 2 cosine squared. 2 sine squared over 2 cosine squared. Our 2's are going to cancel. Sine squared over cosine squared is tan squared, and that was our goal. Okay, for number 18, we're going to want to set the right-hand side as our goal. Hang on a second. Okay, so we're going to want to use our sum difference formulas for the left side. So we have the first one, you can use the formula for sine of u plus v. So look at this off your formula sheet. U is going to be x, v is pi over 6. You're going to do sine u cosine v plus cosine u sine v. All right, so that's the first part. Then bring down the minus sign. Okay, now we're going to do this one over here. So look at your formula sheet for cosine u plus v. And put this in parentheses because it's after a minus sign. So it's going to be cosine x, Okay, cosine x cosine pi over 3, this is from our formula sheet, minus sine x sine pi over 3. Okay, so now we're going to go to the unit circle and we're just going to evaluate the pieces that we can. So cosine pi over 6 is root 3 over 2. Sine pi over 6 is 1/2. Cosine pi over 3 is 1/2. Sine pi over 3 is root 3 over 2. Okay, so notice the parentheses here. I still left them. Now we want to think about distributing that negative sign. So it's going to be minus cosine x times 1/2 plus sine x times root 3 over 2. Bring down the other pieces. Okay, so we've got positive cosine x times 1/2, negative cosine x times 1/2, so let's cancel those. And then the other pieces that we're left with, those are actually like terms. There's 2 of them, so we can put them together by just putting a 2 in front. So altogether it's going to be 2 times sine times root 3 over 2. That 2 in front is like a 2 over 1. This 2 on the top can cancel with that 2 on the bottom. And what we could actually do is put the root 3 in front of the sign, and that was actually our goal. Okay, finally, we're going to use the sum and difference formula to find the exact value of each expression. So we're going to be looking at a formula sheet going backwards. So this is cosine cosine plus sine sine. So that's the pattern for cosine u minus v. U is 65, v is 5. 65 minus 5 is 60. Cosine 60, you can do that on your unit circle, and it's 1/2. All right, next one, sine, cosine, minus cosine, sine. This is the pattern for sine of u minus v. U is 80, v is 50. 80 minus 50 is 30. The sine of 30 is also a half.